Hello class, so we're going to go over how to do the homework. This is a very easy way to do it, and it'll help you on your test because a lot of the test questions come from the homework. So here we go. Now first, of course, make sure you put your name at the top so that if you turn this in, you'll be able to get it back and have your answers with you. So let's start. On the questions, what I normally like to do is when I study, I'll read the questions first. I'll just go through and read all the questions. Then I'll go to chapter 1, Principles of Pneumatics, and I'll start reading. So when I read, it will probably jog my memory for something. So the first question is, the fluid in a fluid power system can be either a blank or a blank. So as I read, starting at section 1.01, I read down, all industrial plants use a fluid power system of one type or another. Work is performed by a fluid under pressure in the system. A fluid power system may function as part of a process such as heating or cooling. It may be used as a secondary service system such as compressed air. A fluid can be either a liquid or such as oil or water or a gas. Wait, hold on. A fluid in a fluid power system can be either a liquid, I think it said liquid, so you write liquid here, or a gas. Now after you find that answer, what I want you to do is where did you find that answer? So you can put section, you can put by here section, or you can just put 101, 1.01. That's what you can do. And then if somebody says, well, where's that answer found? Well, it's found in section 1.01. And then you'll look and there it is. Okay, you have another one. Let's see. In a pneumatic system, the force that does the work is usually supplied in the form of, well, where did I find that? I found that, where did I find it? It is in the same section, 1.01, but it's at the bottom. So let's look at it. A system that uses a gas for transforming force is called a pneumatic system. So in a pneumatic system, the force that does the work is usually supplied in the form of a gas. So that's where you get that from. Okay. Pneumatic is derived from a Greek word for an unseen gas. So that's the next one, form of a gas. And then let's see. The pressure in a compressed air system is caused by the resistance of components and the compressor what? Well, if I keep reading, I'll go down to 1.05, and that's where this answer is. So that answer is about midways. It says pressure is developed by the resistance of the system components and the compressor discharge valves. It's about midways, so discharge right here. discharge. Compressor discharge valves. The amount of force required to start an object in motion or change its motion. Start an object in motion or change its motion is determined by the object's what? Well, if you look at, let's see, 1.07, that's why I found it. It's the first sentence. All objects and substances have mass. Mass represents the amount of matter in an object and its inertia or resistance to movement. So inertia is, and you can also inertia is its resistance to movement. So I'm trying to spell inertia. All right, there you go. I just put it like this. All right, so that's how I want you to do the homework. Now this question right here with the P times 1 whatever, you don't have to worry about that. So anyone with math like this one, you don't have to worry about those. Don't cross them out, because when we go back through the second time, just like this one, when we go back through the second time, we'll cover these. So don't scratch them out, just skip over them. Let's see, one more. Charles' law says that if the volume of gas is unchanged, its pressure will vary with its what? Does anybody know that? It will vary with its temperature. Where is that? I have that somewhere. Will vary. Charles' law is in 1.27. So I'll just write 1.27, and then when you look there, you'll find it. Another physical law dealing with heat is Charles' law. It states, if the volume of a confined quantity of gas remains the same, the change in pressure of the gas varies directly with the change in the absolute temperature. So it'll vary with the temperature. So we'll do this. We'll say temp, or you can spell it all the way out. Now, the reason that is, when you think about Charles' law, that's dealing with something. Say if you have a pressure cooker, when you close it, it's usually at room temperature. When you close it, it has just so much gas that's in it. It's sealed. The gas can't get out and the gas can't get in. But and then it has a certain amount of pressure. But if the volume, which can't change because it's sealed, gets heated, or that volume of air gets heated, the pressure goes up on the inside of it. So, and then when the temperature goes down, the pressure goes back down. You know, a lot of pressure cookers, you can't open them when the heat is high. So you have to cool them down to get them open, so, or relieve the pressure off of them, and that helps to cool it down. So anyway, if you have any questions, just give me a holler. I'll see what I can do about it. Also, just remember to get chapter 1 and chapter 2 done, so when we meet next Monday, we're going to be coming up on a holiday, but when we meet the next Monday, we'll be able to go over these, and we'll have a test on chapter 1 and chapter 2. So make sure you go over them, and if you have any questions, bring those questions to class with you. I'll see y'all around. Thanks. Bye.